This new video is all about the Poisson distribution and how the Poisson distribution is related to the binary or the Bernoulli distribution. So what are we going to establish on this video is how the Poisson distribution itself, which is written as the probability of k as a random variable, is equal to lambda raised to k over k factorial times e raised to the minus lambda. So we're going to explore how this function was derived from the binary distribution. So let's take a look. What is our binary distribution? Binary or Bernoulli distribution. So if you remember correctly, the equation for a Bernoulli distribution is pk is equal to n, choose k, the probability of the success raised to k, and the probability of the failure, which is 1 minus p obviously, raised to n minus k. Alright, so imagine if we did the Bernoulli distribution, but in terms of doing it a finite amount of time, let's say for example 10 times, imagine doing it 1,000,000 times. So it's like tossing a coin 1,000,000 times. But since it's very hard to understand what happens in 1,000,000 times, we can use a program. But in this case, what we will do is try to use mathematics and understand how this function behaves as n goes to a large number. Alright, so how do we write that? How do we mathematically write the Bernoulli distribution as n approaches a large number? So let's write down our Bernoulli, p raised to k, and 1 minus p raised to n minus k. But since we wanted n to be very large, what do? We write limit as n approaches infinity. Alright. So for us to do this, we first need to evaluate what n choose k is, n factorial over k factorial times n minus k factorial raised to pk and 1 minus n minus k. Now what I want to do also, go down a bit, is to designate my mean to be equal to lambda. So that's just an algebraic representation. And remember that the expectation value for a binary distribution is NP, or the number of trials times the probability of success. And since the expectation value is equal to the mean, then lambda is equal to NP. And what we can get from that is that P is equal to lambda over n. Alright, so we can substitute that result in there, and what we get now is this becomes lambda over n raised to k, and the other side becomes 1 minus lambda over n raised to n minus k. Alright, and of course the same thing in here. And so n factorial over k factorial n minus k factorial. And please make sure that all of this is multiplied to the limit as n approaches infinity. Alright, I think we reach a good stopping point. So let's just continue the video on part 2. See you then.